Hi everyone and welcome. So this post was like everywhere on LinkedIn. So I saw a lot of debate about which tank will drain first. I saw some people even driving some equations that will drain at the same time. So let's try to answer this today together. Okay. So from the first feeling or engineering judgment, you will feel that this tank here to the left, it has more water at higher level. This means that it has more potential energy. So this system has more energy and it can drain first. So this is like from the first side. Okay. So let's try to do this in Excel and see what we can do. So here, I will try to divide this tank by different layers. Okay, so let's say for the beginning, let's say we have 10 layers. Okay, and here let's put like it's 20 the radius at the top and 10 at the bottom. Okay, so now let's see the first layer. This will be the elevation or the difference between H1 and H2. This is the radius, and from that we can calculate the volume. And now you can see that I have a rate. This rate it's assumed to be a function of the square root of the height of the level of the liquid in this tank. So at higher level, the rate is more or higher than at lower level, which is, as you know, it's related to the pressure. Okay, so at higher level, it's expected to have higher rate, and at lower level, it's expected to have lower rate. So now you will start to see that because the first tank it has more volume of water at the top, they will drain first. Okay, so this means that bigger amount of liquid will drain first because we have higher rate here and so on. If we do this for the 10 layers, we can see that, okay, for this tank, it needs this amount of time uh, to release this amount of water, okay? And we can also change, if we change the total height, again, we can see some numbers here. So this looks nice, and I did the same calculations here for the second tank, okay, with reverse order of this radius here, and we can see that from the first tank here, let me try to show you. Okay, so this is the second tank here, okay, and these are the numbers. It is almost the same volume, but the time it's more. So I brought them here just for easier to avoid scrolling down or left and right. So we can see that this is the first tank and this is the second tank. So in order to have more accurate results, we can try to increase this amount of layers, making smaller steps, let's say 100. And now you can see again, still the same. Second tank will take more time than the first tank, and almost the same volume here. So we have seen some change in the time, and this is because once we have smaller steps, we have more accurate time calculation. So it was interesting to see if we can derive some differential equations for that. So what I have done here, I have driven these equations, but without a reference. So I'm not sure. I cannot guarantee the accuracy or if they are 100% true or not. But the results from these equations, they look beautiful, to be honest. Okay. So for example, you can see here the integration of the volume. It's 7,326, which is almost this. So this means that just this small piece of equation can give me almost the same accurate volume. The same thing happens for time. If we calculate the time here, it's saying that it will take around 1,850 something, okay, and from here it's 1,770, okay. So we have a small difference in time, but now once we try to increase the layers or taking more smaller steps, we can see that this will go for 1,800 something, which is something almost identical to this. Okay, with more steps, you can see that it's approaching the same number as this one, which means that again this equation it's working fine. Okay, so now this is like giving me an indication that the first tank, which is wider at the top, it's taking less time to drain. Okay, and this answers the question. We can here play with again with this height. If it's just 20-meter height, how it works. If we want to try to have the same diameter, it's just a cylinder, so we should expect that the two tanks will almost have the same time. So hopefully this is a good answer to this question, and thank you.